This is CodeTracer, a powerful time-traveling debugger for Noir. Unlike traditional debuggers, CodeTracer works by recording the execution of a program into a self-contained trace file. You can think of the trace file like a video recording of your program's execution. Once the execution has been recorded, anyone can use this trace file to replay the execution of the program in precisely the same way each time. Now let's see CodeTracer in action. We can step through code normally, or we can step backwards just as easily. And on the right we can find the code trace view. It shows the full history of the executed functions, and it lets us jump instantly to any one of them. We are at the start of this function, but we can already see what's about to happen. All local variables display their values in line. The taken if branches are highlighted and the unexecuted code is dimmed out. Let's step into another function. We can use this slider to navigate through the iterations of the loop, and we can see how the variables change as we go. In the bottom right we can see that the event log also reacts to those jumps. It's essentially a list of all the program's interactions with the outside world. The goal of the example program is to create a zero-knowledge proof that our ship will survive the passage through an asteroid field without disclosing how much energy we have in our shields in the end. That way the space pirates won't know if they can attack us or not. Now let's have a closer look at the main function. According to the comments, the pirates can predict the collisions, but our shield technology is a well-guarded secret. This is why the properties of our shields are passed as private variables to the main function, whereas the masses of the asteroids are public. We can see the exact values in the prover file, which is accessible through the file system panel. Right off the bat we see something suspicious in the event log. In the first event we see 0 damage being done, but every collision should result in at least some damage. And in the next event the shield regenerates beyond its limits. Let's click on the first event and let's see what exactly is going on. Now we are in the status report function. And although the reporting happens here, this is most likely not where we will find our bug. Okay, let's step out of this function. This brought us to the function that iterates through the asteroids. On the first iteration of this loop, we see that the calculate damage function returns 0. Luckily, CodeTracer is a time travel debugger and it's easy to navigate back and step into the calculate damage function. According to the comments, our shields are supposed to get exponentially less efficient as they get weaker. And we see that the current implementation does not take into account the edge case where our shields are at maximum capacity. In this case we multiply the damage by 0 instead of 1. Okay, let's step out of this function and see why in the second event the damage is a negative number. We can use the slider to step into the next iteration of the loop, and here we see that indeed the damage is a negative number. Now we can step into the damage function again, and we can see that the problem comes from the fact that the shield has exceeded its maximum capacity. And this is why in the end we multiply the damage by -10. Okay, now that we know what's wrong, let me fix this really quick by adding an if statement to handle the edge case where we are at full shields in the calculate damage function, and I'll add another if statement to the calculate shield regeneration function so that it cannot regenerate past the maximum shield capacity anymore. After we are done editing the code, we can record the program again and see if everything is working as we expect. Great success! This time the damage is not 0 and the shield does not exceed 100%. But for some reason the assertion does not pass, and I've been told that the example in the prover file is correct, so if we take a look at the event log again, it's not immediately obvious where the problem is. And I know for sure that by the last event the shields should have been drained completely. Luckily we don't have to rely solely on the events from the console output. Let's step into the function where we iterate through the second asteroid cluster. First we can check if we see something suspicious in the variable history. The damage seems to be okay. Let's take a look at the history of the remaining shields. Oh, and indeed we see a negative value appear in here as well. So to illustrate this better, we can create our own events using the trace log. After we open the trace, we can type in a command just like that and press Ctrl plus Enter. If we click on the event where the remaining shields are negative, CodeTracer will jump to that event. Now we can see that in all the events after iteration 4, the shields should have been drained, but we don't stop regenerating the shields even after that moment. To fix this issue, I will add another if statement to the calculate damage function, which will limit the damage to not be greater than the remaining shield. And since we need to have at least 1 unit of shield energy to survive the cosmic radiation, I will add another if statement to apply the regeneration only if there is at least 1 unit of energy left. Let's see if everything works as we expect. This time all assertions pass, which is a good sign. And I don't see anything suspicious in the event walk. And even if you take a deeper look into the variable history, we don't see anything suspicious again. So I guess that's it for today. Feel free to join our Discord server, and if you want to support CodeTracer, you can leave a star in the GitHub repo. Links are in the description below.